Hey guys, welcome to the video. Today we're going to talk about the second step of the programming development cycle. Okay, so we last week talked about step one, which was about understanding the problem. Now we're going to focus on step two, planning the logic. So a big question that, this talks about is what is the heart of the programming process? And the heart is pretty much found in, planning the logic, planning the program's logic. Okay. And this stems to a couple more questions when we talk about this topic. Okay. So let's talk about these questions. So in the phase of the process, or in this phase of the process, what does the programmer do? Well, they focus on planning the steps of the program. After they have this plan set up, they decide what steps to include and then also how to order these steps. So, what are the two of the most common planning tools that programmers use? We have things like flowcharts. Flowcharts pretty much are a way to pretty much plan the logic of a program. For example, in a standard flowchart, we have the start, which is pretty much an ellipse symbol. And then we have an arrow, which pretty much is the next step. This is all like a step-by-step order, okay? So in this next step, we have a sort of parallelogram looking shape. And in this parallelogram looking shape, we have an input. We can put an input user variable. We create an input user variable where we're going to input a number, apparently. Actually, I need to correct myself here. We're not inputting a value into this user. We're just creating the variable that's going to be an input to our program. Then our next step is that we're gonna be creating a variable called user answer. Okay. And pretty much we'll be setting this user answer, okay? And then here's the thing, this is gonna because this is a rectangle, this is going to produce a calculation. So basically this is a multiplication equation here, where the answer is user answer, which equals the user num that we created in the previous step times 2. Okay? So going back to user num, we actually are inputting a value to this, okay? Which will then be used to calculate the formula that we have in this rectangle. Once this is done, the next step is an output. And as you can see, it's also parallelogram as input. And when it comes to flowcharts, if whatever is an input or an output, it will have this parallelogram shape here, okay? And as you can see, we're outputting the variable user answer. And then the next step, this arrow will go to this other ellipse shape, and and the program then stops. So we just talked about the first tool, which is the flowchart. We also have a second tool that we use for planning, which is pseudocode. And pretty much it's the literal version of a flowchart. As you can see, the way we write pseudocode is we have start, okay, keyword, and then afterwards we use indentation to pretty much clarify this is what's inside the program, okay? We, you know, we have an user num variable that's created. We might actually bind a value to it. And then we go to the next step. We go to the next line for the calculation step, and then next line for the output step. And then we stop the program, and it's in the outer. This is not indented. Okay, so this is pretty much the same idea when you write pseudocode. Okay, so Is there any superior way or superior reason to use either one? In my years of studying this, there is no superior way. You go with whatever works best for you. And besides, there are other types of planning tools that exist in the computer science world. So, what do both flowcharts and pseudocode involve? So, the key idea here is pretty much that we're writing the steps of a program in English. We're not writing code, we're just writing the steps, the logic of this program in English. And how could we compare this step to? So, it is like writing the ingredients of a pizza before you go out to the grocery store and buy them. Or in another case, in another scenario, it's like writing the ingredients to a cake, a homemade cake, before you go out to the grocery store or to Walmart and buy those ingredients. Okay. It is also like writing down your tasks for the day on your notebook before you start your day. Okay. Basically, before you do anything, you have to know what you're gonna do, what is going to be required. Okay. One aspect of programming is that you need to know the requirements of the problem for whatever project you're undertaking. Because if you understand the requirements and you understand the problem, you'll be able to create a program that solves the problems of your client. Now, on a different topic, but very, very connected, okay? What is an algorithm? And as I was saying earlier, I did say it was disconnected, but it's not really. Algorithm, the word algorithm has a lot to do with what we just talked about a few instances ago. Algorithm is a sequence of steps that are essential to solving any problem. Okay? Now, going back to the idea of pseudocode and flowcharts, what are some variety of other tools that programmers can use to help in the program development? And here's three examples. We have IPO charts, TOE charts, and UML charts. In this scenario, in this step, we're not really going to focus on these charts. We're just going to focus on the two big ones that we just talked about, pseudocode and flowcharts. Now, in planning the code, in planning the program, should we worry about syntax? And in your situation, we're not really worried about the syntax of the code. We're actually just focused on the logic of the code, on the steps, on the sequence of steps that our program will have to do in order to reach a certain behavior, in this case, maybe a result that we want, that we intend the program to have. So no, there is not of any particular programming language. We do not have to worry of any syntax of any programming language. We're just focused here in this step on just the logic. So, going back to the idea and rephrasing it again, how must we focus on? Or what must we focus on? And it is on the big idea is that we must focus on figuring out what sequence of events will lead from the available input to the desired output. Going back to the idea, it's pretty much this. Our input, our process, or in this case, calculation, and the output that we want. Basically, the output of a value, a product of an algorithm, of an expression, of an equation where you inputted a number and it got multiplied by 2. In this case, let's just say I inputted 10, okay, for user num, and it got multiplied by 2. The desired output should be 20. If it's 15 or 18 or 100, that is not the desired output. And something happened in the process. Okay? So that's pretty much the big idea. It's figuring out what sequence of events will lead from the available input to the desired output, which in the example I just gave you, I input 10, there's a calculation of 10 times 2, and our desired output will be 20. This will be a big deal moving on further. As you study more in programming, we'll be talking about ideas like semantics and syntax. And semantics is pretty much about the behavior of the code you're writing. Sometimes your code can be written correctly and it can compile and work. However, the results that you get may not be what you had intended. Basically, the program will not behave the way you wanted it to behave. This is something I'll be talking about in maybe other videos on different topics. This is really a bit more advanced, but this is really connected to the idea of semantics in many ways. That's all you have to know for the moment. So, what are the two core ideas does planning the logic include? Well, it is about thinking carefully about all the possible data values a program might encounter. And number two, and how you want that program to handle each scenario. So, in the world of computer programming, there's this concept called desk checking. So you might ask yourself, what is desk checking? So desk checking is the process of walking through a program's logic on paper before you actually write the program. Oh yes, don't think computers programming is going on a computer and just writing the code. No, no, no. As you guys have seen in the program development cycle, we have a step where we have to pretty much go through the process of a program before we even get to a desktop or a laptop and start writing the code. You have to learn how to design the program, whether it's through pseudocode or flowcharts, or maybe using a UML diagram, which we do use a lot in Java. Java is a programming language that we use. Okay, but the point here is there is a initial planning step that might require you actually write the steps of the program and what it's going to do before you actually touch a desktop or a laptop and start writing the code. Start typing the code. So yes, this is what that section's all about. And before you even get to your laptop, you do need to pretty much check that what you're writing on a paper is, actually gives the user, gives the user and even the programmer the right output, as we just talked about. And that is it for step number 2, planning the logic in the programming development cycle. Okay. So, guys, if you guys have any comments or any questions, don't hesitate to ask them. And please like and subscribe. Any help, subscription to this channel will pretty much help this channel grow and help me improve in sharing and also presenting this information that I've learned throughout my years in studying computer science. Thanks, guys, and may I see you guys in the next video.